Checkup number 1, revisit your checkup number 1. Why are we going to revisit? We're going to revisit so you can improve how you did. So the purpose of this video is to review the math vocabulary. These are words from our word wall: factors, multiples, prime numbers, composite numbers, and square numbers. As you view the video, pay close attention to the examples shared and vocabulary reviewed. Fix any of your answers and please highlight them with a highlighter. So whatever you fix or whatever you write down as a second try, highlight it. If you need a highlighter, see Mr. Kruger. Here is a picture of the checkup 1. On checkup 1, you can see that the first 2 questions deal with factors, and then we go into prime numbers, composite numbers, multiples, square numbers, and then once again, factors. So, for problem number 1, I'm going to do that here. 1 and 2 deal with factors. So what's a factor? A factor are numbers multiplied to get a product. I'm going to do an example now. You watch. What are the factors of 12? Students, it's easiest to write down factor pairs. So think of all the ways you can multiply 2 numbers to get 12. That will give you your factor pairs. So we can say 1 times 12, 2 times 6, and 3 times 4. Each of these is a factor. So those are the factors of 12. In the video, you needed to list the factors of 24 and the factors of 31. So now you can retry problem 1 and problem 2, factors. The next concept or math vocabulary term is prime numbers. Prime numbers. So what is a prime number? A prime number is a number that has only 2 factors, 1 in itself. I will list some primes. Let's pick a prime. 2. 1 times 2. Those are the only 2 factors. 13 is prime. It only has 2 factors, 1 and 13. How about 17? 1 and 17. So those are prime numbers. In example 3, you need to give 2 examples of prime numbers. Please don't use the primes I used. I'm just moving things out of the way here. The next term, composite numbers. And composite number is what question 4 is asking. So what's a composite number? A composite numbers are numbers that have more than 2 factors. You need to come up with 2 examples. I will do a couple examples for you. Here's a composite: 6. 1 times 6, 2 times 3. This number has 1, 2, 3, 4 factors. I wrote them down as factor pairs. Let's do another example. 18. 1 and 18, 2 and 9, 3 and 6. This number is composite because it has more than 2 factors. 18 has 6 factors: 1, 2, 3, 4, 5, 6. Composite numbers. All right, square numbers. What's a square number? So square number deals with question 6. Actually, I missed one here. I should have written down multiples. So let's look at number 5. List the multiples of 12. What is a multiple? Multiple, I like to say, as you've heard me say in class, is just skip counting. Any whole number multiplied by another whole number. So a lot of times when we do multiples, we take a number such as, let's do 5. So what are the first 5 multiples of 5? So we say 5 times 1 is 5. 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25. These are multiples. It's just skip counting by the number. So it's 5, add another 5 is 10, add another 5 is 15. Oops, I wrote 24. This should be 20, obviously. Add another 5, 20, add another 5, 25. So 5, 10, 15, 20, 25. Multiples skip count. Let's do another example. Let's use a different number. Let's use a prime number. Let's use 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. Those are multiples of 7. They are not factors. Multiple is skip counting by the number. They are not factors. Okay, so that should help you with number 5. Now let's go on to number 6. It said, which of these are square numbers? Which of those are square numbers? And it could be more than one number. So what's a square number? A square number, the product, answer to a multiplication, the product of any number multiplied by itself. So you're looking at these numbers and saying, is there any two numbers, any number multiplied by itself that will give you these products? Let's do a couple examples of square numbers. How about this? 2 times 2 equals 4. 4 is a square number. 3 times 3 equals 9. 9 is a square number. 4 times 4 is 16. 16 is a square number. So once again, any number multiplied by itself will give you a square number. So over here, are any of these square numbers? So are there any two numbers, such as for 25, is there any number multiplied by itself that will give you 25? Do that for 36 and 48 as well. Number 7, decide if this statement is true or false. Explain your reasoning. 1, 2, 3, 4, 6, 9, and 18 are all factors. So we went through factors already in this video. If you need to rewind the video to hear about factors again, you can do that. And the last one, is 18 a square number? That means, are there any two numbers that you can multiply? Any two numbers, this times this, that will give you 18. Remember, highlight any changes you've made to your assessment, and then you can turn it back into Mr. Kruger. Thanks for listening to the video, and thank you for the extra effort.